Alright, welcome back. MECH2320 motor control. We're looking at chapter 33. We're going to talk about consequent pole motors. Important piece of, aspect there as we are talking about the poles. Okay, so what's the point of a consequent pole motor? Changing the frequency of the applied voltage and being able to change the number of stator poles per phase. So those are really kind of two of the key characteristics that we're going to be talking about. Why is that? Because that's our ability to change speed. Okay, so consequent pole motors, it's so that we can change speed. Also, maintain a high torque while the speed is reduced. Okay, so when we do this, two-speed consequent pole motors contain one reconnectable stator winding. So essentially, we have the ability to change speed, and we change that speed by changing the number of the stator poles. Okay, so if we take a look here, and this is a chart, okay, we have the number of stator poles, so it's 2, 4, 6, 8. And then we have hertz. One's 60 hertz for us, Canada, and then 50 hertz for Europe, rest of the world that runs on 50 hertz. So it's how we impact this. We are going to hit this a little bit harder in the VFD drive as well, because it'll cover how changing poles and that sort of thing does as well. But for us, okay, with the synchronous motor, the VFD drive is changing frequency with the controls. So let me back up so I don't confuse you there. The VFD drive, all right, we're programming it, we're changing the frequency on it. The synchronous speed, okay, that's changing the frequency because we're changing the number of poles. So it's like a VFD, but it does it a little bit differently, and it's how we're sending current through the wires. Okay, so we can see based on what speed we're going to get. So if we have a 60 hertz frequency coming in, and we have two stator poles, all right, we're going to get 3600 RPMs. If we're still at 60 hertz and we have 6 poles, we're going to get 1200 RPMs. Okay, so it's going to be different based on the number of poles. We're using the poles to change the frequency, which impacts our revolutions per minute of the rotating shaft. So this kind of gives a very good sum up of what's going on here. If we have a 2-pole 3-phase motor, okay, we can see that think of this as kind of a clock: north, south, north, south, north, south. Whereas if we're looking at the other one, right, we got north, south, north, south, north, south, north, south. We have a 4-pole 3-phase motor. Okay, so we're changing poles more. All right, but the field travels through the same number of poles during each complete cycle. So what's really happening there is, if we take a look, the top one, okay, there's 3 norths, 3 souths, okay, and look at the bottom one, still 3 norths, 3 souths, but it's how we're hitting those poles as it's rotating around. Okay, so I'm going to back up a slide here just so you can take a look. Now that might make more sense. So if we want it to spin faster, right, we want less, and if 60 hertz is constant, okay, if we want it to spin faster, higher RPM, less poles. More poles, okay, we have a slower RPM. So that's really what we're doing with this motor. Based on the number of poles is going to control, how fast the motor is. So less poles, more RPM, more poles, less RPM as we go through this. Okay, and how does that really work? Well, if we take a look at how the current's flowing through, okay, if it's going in this series type direction here, it's going to make one pole. You can basically look at how the current is flowing in series and making one pole. If the diagram on the right, okay, if we have current direction in the opposite through each, that's how we make 2 poles. Okay, so we can control how many poles are really happening on this motor here. Okay, and when we control the direction of the current, we're controlling the direction of the magnetic field, and that's really what we're doing. That's what's going to give us the north and south direction when we do that. Okay, how does that happen? All right, so this is, I'm going to kind of roll through this one because this is more of a you're using it in the field type scenario. But really, essentially, for us to get all the different settings we want, all we're doing is changing the different types of connections that we have for that current path to change. All right, so if I step back to this one, it's how we're wiring it up to change the current paths that are going to create the number of poles that we're going to have. Okay, so if we look, we have a series delta and parallel Y. So for that, we get the same horsepower. Okay, if we have a series delta with low speed, the parallel Y gives high speed, we get the same torque. So there are going to be opposites of each other, and it depends on if we want, speed or torque. Okay, and if we were looking at the plan drawings for it, we would be able to look and see on here where the power connections need to be made, okay, in order for that to happen. Okay, and how we would change the number of poles. So if you would take a look at how you wire it up and make the connections. If we want 3-speed pole motors, okay, so I'm going to kind of go through this. So this one we're looking more for constant speed, and there's how you would make the connections. We want constant torque, we would have these type of connections. Okay, so it's really just kind of based on the application that you want, to be able to control your speed. But you're controlling speed by changing the number of poles. That's really all you're doing. You're changing the number of poles, and you're changing the number of poles by changing the directions of the currents and the windings. Okay, and you can take a look here. Even if you look at the chart on here, it tells you how to connect everything. If you want low speed, second speed, third speed, high speed, it's going to tell you, where you connect line 1, line 2, and line 3 so that you actually get those. Okay, and this would all be connected so that we could have constant horsepower. So it's really kind of understanding the charts here, as we go through these, and understanding the connections. And based on how we connect and bring our line power in, and how we connect everything together, that's going to give us what we're looking for. And you can see I can go through a whole bunch of these. The book goes through a whole bunch. If we want to look at constant torque, what do we connect line 1, 2, and 3 to? Okay, and then we leave the other ones open, which means no connection. So if we want second speed, we would tie L1 to T6, L2 to T4, L3 to T5, and all the others, okay, would be together, T1, T2, T3, and T7. Okay, we're changing the paths for current to go through. Okay, I don't expect you to memorize any of this. It's going to come with the motor, and the motor. One of the motor labs you're doing, right? You have to read the schematics anyways, and it's going to tell you what to hook up to where. So you're going to have to do that in one of our labs. All right. So like I said, we can go through all these if we want: variable torque, constant horsepower, all variable speed, or constant speed. So, it's just going to be the different connections where we're bringing our line power in and how we're connecting all the other windings up. So, hopefully that kind of makes sense. Okay, but that's what a consequent pole motor is. We're changing the number of poles, all right? That's going to change the speed. And just to reiterate, the less poles, okay, the faster the rotor will go. The more poles, the slower the rotor will go. And we're controlling the poles based on doing the windings, and how we're bringing line 1, line 2, line 3, our power, okay, our 3-phase power, all right, and how it's terminating and how we're sending the current through, because remember how those are wound, they give off the magnetic field. And we talked about this electrical. You put your thumb in the direction of the current, and the left hand will thumb in the direction of the current, and your fingers will curl in the direction of the field. So that's how we're able to control the direction of the poles. All right, well, that's the end of this lecture. If you have any questions, don't forget, you can always email me or let me know if you need a team meet or a Zoom meet after this one. Else, guys, have a great day. See you in class.